Hello, everyone, and welcome to this introduction to DevOps Fundamentals for Beginners. In today's session, we are going to understand what DevOps is, why organizations are adopting it, how the DevOps lifecycle works, the culture behind DevOps, some of the most popular DevOps tools, and finally, why Linux is so important in the DevOps ecosystem. DevOps is fundamentally about bringing development and operations together to build, automate, deploy, and continuously improve software. Instead of treating development and IT operations as completely separate functions, DevOps creates a continuous flow where teams collaborate, automate processes, monitor applications, and continuously improve the way software is delivered. So let's begin by understanding what DevOps really means. So, what exactly is DevOps? The word DevOps combines development or dev with operations or ops. DevOps is a culture, a set of practices, and a collection of technologies that bring software development and IT operations together to deliver software faster, more reliably, and with higher quality. Traditionally, development teams focus on writing and delivering code, while operations team focus on deploying, running, and maintaining applications. This separation can create communication gaps. For example, developers may say the application works perfectly on my machine, while the application or the operations team may face completely different issues when deploying that exact application into production. So, DevOps attempts to eliminate these silos. It encourages collaboration, automation, continuous integration, continuous delivery, faster feedback, and continuous monitoring. But why do organizations need DevOps? So, traditionally, software development can involve slow releases, manual deployments, communication problems, and repetitive operational tasks. DevOps addresses these challenges by combining people, processes, and technology. The result is faster delivery, better collaboration, greater automation, improved reliability, and continuous improvement. The presentation specifically frames DevOps around collaboration, automation, CI/CD, feedback, monitoring, and operational excellence. Now, let's look at one of the most important concepts in the DevOps lifecycle. The lifecycle shown here consists of 8 major stages: plan, code, build, test, release, deploy, operate, and monitor. Let's quickly understand each stage. First is plan. This is where teams define requirements, establish goals, gather information, and plan the roadmap. Next one is code. Developers write and commit source code using version control and development best practices. Then comes build. The source code is compiled or packaged, and build artifacts are created automatically. After that, we have test. Automated tests are executed to verify functionality, quality, security, and performance. Next is release. The application is approved and packaged so that it is ready for deployment. Then comes deploy. The application is automatically deployed into the target environment, such as staging or production. After deployment, we enter the operate stage. Here, teams run and manage the application in the production environment. Finally, we have monitor phase. Teams continuously monitor application performance, logs, infrastructure health, and user experience. And the important point is that this isn't a straight line. The results from monitoring provide feedback that goes back into planning and development phase. That is why DevOps is represented as a continuous loop or an infinite loop. The lifecycle diagram here explicitly presents these 8 stages and describes their activities. So, why is DevOps important? The first major advantage is faster software delivery. Automation and streamlined processes allow organizations to release features and updates much faster. Second is improved collaboration. DevOps breaks down the traditional barriers between development and operation teams and encourages them to work toward a common objective. Third is automation. Instead of performing repetitive tasks manually, teams can automate processes such as testing, building, deployment, and configuration. This improves efficiency and reduces the possibility of human error. Fourth one is better quality. Continuous testing and monitoring allow teams to identify problems earlier in the development and delivery process. Fifth is reduced downtime. With proactive monitoring and faster issue resolution, organizations can respond to failures more quickly. And finally, DevOps enables continuous improvement. Teams can use feedback, metrics, and operational data to understand what is working, what isn't working, and where improvements can be made. So, DevOps isn't simply about deploying software faster, it's about creating a system that allows organizations to deliver value faster without sacrificing quality and reliability. Now let's compare traditional IT development with the DevOps approach. In a traditional environment, development and operations often work as separate teams. This creates silos and can limit communication. With DevOps, we move toward collaborative, cross functional teams. The second difference is deployment. Traditional environments may rely heavily on manual deployment, which can introduce errors and inconsistencies. DevOps uses automated deployment pipelines to make deployments more consistent and repeatable. The third difference is release frequency. Traditional releases may happen infrequently and can take weeks or even months. DevOps encourages continuous releases where smaller changes can be delivered more frequently. The fourth difference is monitoring. Traditional environments may rely on reactive monitoring, where problems are discovered after something fails or a user reports an issue. DevOps promotes continuous monitoring, allowing teams to identify potential issues proactively, which is before even the issue is reported or identified or happened. Finally, traditional environments can experience longer recovery times. DevOps focuses on faster detection, response, and recovery. So, the overall transition is from separate teams, manual processes, slow releases, and reactive operations toward collaboration, automation, continuous delivery, and faster recovery. The comparison shown here represents these five contrasts directly: separate versus collaborative teams, manual versus automated deployment, slow versus continuous releases, reactive versus continuous monitoring, and longer downtime versus faster recovery. One of the most important things to understand is that DevOps is not just a collection of tools. DevOps is also a culture, and that culture is built around people, practices, and mindset. The first element is collaboration. Development, operations, security, testing, and other stakeholders need to work together rather than operating in isolated silos. Second is communication. Open and transparent communication helps teams build trust, maintain alignment, and make decisions faster. Third is automation. Teams should automate repetitive tasks wherever practical to improve consistency, efficiency, and reliability. Fourth is continuous learning. Technology continuously changes. So, DevOps teams need a mindset of learning, experimentation, and adaptation. Another important principle is shared responsibility. Instead of saying that is the development team's problem or that belongs to operations, DevOps encourages everyone to take ownership of the outcome. And finally, there is customer focus. The goal is not simply to produce more code, the goal is to deliver value that matters to customers and continuously improve their experience. So remember this, culture is the foundation of DevOps. Tools comes after the culture. Let's summarize the major benefits organizations can achieve through DevOps. First one is faster deployment. Automated delivery pipelines allow organizations to move changes from development toward production more efficiently. Second, better collaboration. Teams work together with improved communication, transparency, and trust. Third, high availability. Continuous monitoring and proactive issue resolution can help organizations build more resilient systems. Fourth, improved quality. Code reviews, automated testing, and quality gates help identify problems earlier. Fifth, automated testing. Testing can be integrated throughout the delivery process instead of being treated as a separate activity at the end. Sixth, faster recovery. When failures occur, teams can detect, respond, and recover more quickly. 7. Reduced costs. Automation reduces manual effort and helps organizations use their resources more efficiently. And finally, continuous improvement. Teams can use metrics and feedback to continuously optimize their process. Ultimately, DevOps helps organizations deliver faster, work better together, operate more reliably, and continuously innovate. Now, let's look at some popular tools used across the DevOps lifecycle. For version control, we have Git. Git allows teams to track changes to source code and collaborate on development. For code repositories and collaboration, we have platforms such as GitHub. For the build stage, the presentation highlights Maven, particularly for Java projects. For CI/CD, we have GitHub Actions, which can automate build, testing, and deployment workflows. For containerization, we have Docker. Docker allows applications and their dependencies to be packaged into a container. When we need to manage containers at scale, Kubernetes provides orchestration capabilities. For infrastructure as a code, we have Terraform, which allows infrastructure to be provisioned and managed through code. For configuration management and automation, we have Ansible. And for monitoring and visualization, we have tools such as Prometheus and Grafana. The important thing to remember is that DevOps does not mean learning one single tool. DevOps involves integrating multiple tools so that the entire software delivery lifecycle becomes automated, measurable, and repeatable. Another important foundation for DevOps is Linux. Why is Linux so important? First, Linux is widely used in cloud and server environments. Second, It is open source, which means it can be used, modified, and distributed with support from a large global community. Linux is also known for being stable and suitable for environments where reliability and uptime are important. Another major advantage is its powerful command line interface. DevOps engineers frequently use command line tools to manage servers, automate processes, troubleshoot problems, and execute scripts. Linux is also highly suitable for automation. Shell scripts and other automation tools can be used to perform repetitive administrative and operational tasks. The presentation also highlights Linux as powerful, flexible, developer friendly, and cost effective. So, if you are planning to build a career in DevOps, cloud, system administration, or automation, developing strong Linux fundamentals is extremely valuable. Linux isn't simply another operating system in the DevOps ecosystem, it acts as an important DevOps enabler. DevOps is not just a process or a set of tools. It is a continuous way of working that combines collaboration, automation, delivery, monitoring, and improvement. Thanks for watching. Keep learning, keep automating, and keep improving. See you next session. Thank you.